What you're about to see is a reminder that this advisor webcast is intended for information purposes only. Any features or functionality described for Oracle's products remains at the sole discretion of Oracle. So let's go ahead and get started with our presentation. Praveen, if you're ready, I'll turn the webcast over to you and you can begin.
Yeah, thanks, Nick. Hello, everyone. Welcome to the WebEx for the today's session. We are going to discuss about the parallel execution in the database. The topics or agenda of this session is as follows: parallel execution basics, parallel execution terminologies, PX architecture, distribution methods, trace interpretation, and PX errors. So let us look at parallel execution basics. In case of serial execution, the work will be carried out by only one of the process. And in parallel execution, the work will be broken down and it will be divided into smaller subtasks. So it's commonly used method for speeding up of the operations by splitting to the subtasks. To get most out of the parallel execution, following are the prerequisites which need to be met: efficient parallel execution plan, sufficient resources available at the time of execution, no significant skew of work distribution across parallel sleeves. Not limited to this, but these are main prerequisites which we can see. Where we can say parallel execution is better choice. So the conditions are as follows. Right? The query references to large data set, and if there is a low concurrency, elapsed time is most important. In these cases, we can use parallel execution. And when it is better to use a serial execution rather than parallel execution. So the query references to small data set, there is a high concurrency and efficiency is more important. In that case, serial execution is better choice. So serial execution is typically useful for the environments where the typical query transaction is very short. For example, if the query requires a very short time, and in that case, serial execution is better than parallel execution, because parallel execution will consume or require resources. So it's a resource intensive operation. If enough resources are not available or they are required for any other query, typical query or large query, then it can be used for the parallel execution. Environments where CPU, memory, or IO resources are heavily used. In this case, serial execution plan execution can be used. So fundamental hardware requirements of parallel execution. So it's designed to effectively use multiple CPUs and disks to answer queries quickly. Parallel execution typically performs large random IOs. It is very IO intensive by nature. So most of the parallel executions will require IO, and it also depends on the number of CPUs present in the server. So the more CPUs, more benefit from the parallelism. Require sufficient memory for additional parallel process, sorting, hashing, and IO buffers. So these are the high-level fundamental requirements for the parallel execution. So there are different ways to enable the parallelism. We'll see what are the different ways. So at database level, it depends on the parallel max servers parameter. If it is set to 0, then parallelism will be disabled at the database level itself. But the internal queries which are coming in or which are running in the database, it can be still run in parallelism. So this parameter controls for the user or customer user-related queries, especially. And at statement level, we can enable a parallelism using a hint with a parallel clause simply. If we are not using any integer, then it is a default parallel. and it depends on the CPUs present in the host. And parallel 4 or parallel 2 we can keep. And if you wanted to use parallelism for a specific object, then it can be decorated with the object name and required number of parallel. This overrides session and object level DOP settings. Session level, we can enable session level parallelism as follows: alter session force, parallel query, or parallel DML, or parallel DDL, and parallel 8. So this value can be based on the requirement, it can be given. Alter session enable parallel DML. So this is for data manipulation, DML queries related one. So if you wanted to perform any DML operations in parallelism, this can be enabled at the session level using the query. Overrides the object level DOP setting. And we are giving a session level, then it overrides the object level DOP setting. Object level, we can give alter table name, parallel, whatever the value we are going to fix for that object, parallel 2 or 4 or 8. In the same way, alter index name, parallel, and then required DOP. There are many other parameters for parallelism. So the other can be checked over the Oracle documentation, but these are the basics of the parallel execution things. Now we'll see PX terminologies. So we have different terminologies in parallel execution. The first one is query coordinator, which is called as a QC. So the session ID which fires the parallel query becomes QC. For example, if session 1 is triggering a query, so it will be acting as a query coordinator. And parallel execution servers, parallel slave processes. So it will be referred as P0 to Pn or PQ. In case of rack, PPA process can be seen. Degree of parallelism will be referred as a DOP or degree. Slave set referred as SS1 or QS1. So slave set consists of PX number of processes, which is defined in the DOP. A complex query usually requires 2 slave sets. Please make a note of this one because the most of the complex queries will require 2 slave sets. Producers, it will be called as P0 to Pn, like all the parallel slave processes. So this will be producers rows to consumer set. Scanning operations kind of thing, it will be done by the producers. Consumers will be getting the rows processed by the producers. For example, sorting or joining operations will be done by the consumer activities. DFO, data flow operations, or PX server set. So a DFO, it's a basic unit of work carried out by the PX servers in an execution plan. The set of PX servers working on DFO is called PF server set. The number of PX servers in a set determined by the statement DOP. This we are going to see in upcoming slides, how it will be arrived. So PX server pool. Oracle allocates PX servers to the statements from a pool of processes. And this is determined by the parameter parallel max servers. So this parameter acts as the limit for the number of PX servers that can be spawned by the database instance. And the formula of this parameter's value can be calculated using below. So parallel threads per CPU multiplied by CPU count multiplied by concurrent parallel users multiplied by 5. So the concurrent parallel users, how we are going to decide that value, how it is going to be derived. So if the memory target or SCA target is set, then concurrent parallel users value will be 4. And if no memory target or no SCA is set, only PGA aggregate target is set. In that case, its value will be 2. If no PGA aggregate target is also, then it is set to be 1. So parallel max servers is the limit that can be spawned in that particular database. For example, if you are defining parallel max servers to 100, so 100 parallel slaves servers can be spawned during the PX operations. The parameter applies to parallel execution in exclusive mode as well as in real application cluster as well. I will see a simple example. So here the explain plan of a select, which is using parallel 2, and it's just select star from a table. Here we can see PX plan, a parallel execution plan. So PX send QC, we can see here, line number 2. So the degree of parallelism is 2 because of it is using hint. We are giving explicitly hint over there. So as a general rule, DFO boundaries are indicated by 2 columns in an execution plan. That is PX send in the operation column or TQ in the name column. So this indicates DFO boundaries. In this plan, we see that we have only one DFO indicated by the line ID 2. This means this statement will use one PX server set having 2 PX servers because DOP is mentioned as a 2. So this, make a note of it. How about the DFO will be defined and all. So here we can see only one DFO. Only very basic statements like select star from table can be executed with a single DFO. But most of the queries will be having more than one DFO. So the following example, it shows 2 DFOs. That means 2 PX servers are being used. Here parallel hint is 2 only, but there is an additional clause has been added in the select query. So that is the reason it has used 2 DFOs. The DFOs we can see from here, line ID 2 and line ID 5. These are the 2 DFOs, data flow operations it will be called. Since we have 2 DFOs in these statements, we'll use 2 PX server sets. So each set will be having 2 PX servers, as the DOP is 2 in this case. So total 4 PX servers will be worked for this query. One PX server set will perform line ID 5 to 8. The other set will perform from line ID 2 to 4. DFO tree or parallelizer. So that will be called as interchangeably this DFO tree and parallelizer. Any PX coordinator in an execution plan, it will be called as a parallelizer. So in the above example, we can see there may be a multiple DFOs under a parallelizer. These DFOs are grouped under a DFO tree. So here we can see PX coordinator. There is only one PX coordinator is there, which is at line ID 1. And below that, we can see 2 DFOs, which is line ID 2 and line ID 5. So this means 2 DFOs are there. So in the above example, we can see there is only one parallelizer. So meaning only one DFO tree is there. The DFO tree in the plan is carried out by at most 2 PX server sets. So if there is only one DFO under DFO tree, as the first example shows, in the earlier example we saw there was only one DFO under DFO tree. That means PX coordinator was 1 and PX send QC, that one we can see is it as a 1. So one DFO tree and one DFO. And if there are 2 or more DFOs under DFO tree, 2 PX server sets will be used. So, and we'll limit the number of PX server sets to 2 for a DFO tree. This is why most of the statements use 2 PX server sets, meaning they will be used DOP into 2 number of PX servers. This we have discussed in the initial slides. This is the max, most of the queries will be used 2 DFOs. Now let us look how the 3 DFOs query looks like. Here the same parallel 2 hint has been used and some more clauses has been added to the query, which is simple select query. Even though we have here 3 DFOs, there is only one DFO tree, that is one PX coordinator. In the line ID 2, we can see it as a PX coordinator, and the line ID 3, 8, and 15. These are DFOs. So 3 DFOs are there under a single DFO tree. And here the parallel MAC servers will be 4 PX servers it will be used because the DOP is 2. How we can find the number of parallelizers or PX servers set for a query? So we can find based on the view PQ sesstat. And in the last example, if we see how we can see for that query, how many DFOs or slave sets for span, we can use the view $PQ sesstat. If it is a system level, we can use $PQ sesstat. There are other views also to check about the parallel queries, how it ran. So in this case, we queried select star from PQ sesstat. So DFO trees, we can see it as a 1. This is for the initial example which we saw. The DOP is 2 and slave sets will be 2. So this was for the query execution, and it was after the immediate execution of the query. If we run PQ sesstat, this will be shown. So now we'll see multiple parallelizers. That means different or multiple DFO trees. So the number of PX servers used by SQL statement is determined by the statement of the degree of the parallelism and the number of parallelizers. This we have discussed in the earlier slides. So because the number of PX servers set for a parallelizer is limited to 2, most of the PX servers for the most statement, it will be DOP multiplied by 2. Some statements can have more than one parallelizer because each parallelizer can use 2 PX server sets. So the number of PX servers for this statement can be more than DOP multiplied by 2. We are going to see in the upcoming slides about this one. So we can identify these statements by looking at the explain plan of the query. If the plan has multiple PX coordinators, it means that statement has a multiple parallelizers. That means DFO trees. Some of the examples where SQL statement use multiple parallelizers can be subquery factory, grouping of sets, star queries, in-memory aggregation, and non-correlated subqueries. These are few examples where multiple parallelizers can be seen, but not limited to these. Multiple parallelizers in a SQL statement can be active concurrently or one after the other, depending upon the execution plan. This is another example where we can see multiple parallelizers or DFO trees. So here at line ID 2, we can see on line ID 7, there are 2 PX coordinators. That means 2 parallelizers or DFO trees. So DFO trees are 2 and server threads are 6 in this case. The server thread statistics, it will show as a maximum number of PX servers used concurrently for a SQL statement. Now we'll see PX architecture. This is the high-level architecture, how the producers and consumers will look, will act as in the query execution. Here we are using a select query with a parallel hint 4 and some conditions in the query. Consumer set we can see and producer set we can see. These are the 2 slave sets. The producer set, it is performing the scanning of the rows from the tables, and the activity is being handed over to the consumer slave set. And these consumer slave set will be handing over the result to QC, that is query coordinator. And QC will hand over the result to the end user or session. In this case, same process may act as both consumer and producer, but intermediate stages of the execution. So it will be decided by the optimizer, which set will be acting as a consumer or producer, how it is being interchangeably working internally. So parallel DOP hint is 4, so it will be spawned as 8 slaves because the DOP multiplied by 2. So 4 multiplied by 2, 8 slaves will be spawned for the query. I will see PX distribution methods. In a query, while running a parallel query, there will be different methods will be running internally. So these are some of the distribution methods between the producers and consumers. This can be found from the execution plan of the parallel execution. So the first one is a hash distribution. In the execution plan, we can see it as a PX send hash. When we see the PX send hash means it's a hash distribution method has been used. So this method uses a hash function on one or more columns in a row, which then determines the consumer where the producer should send the row. So this distribution attempts to divide the work equally among the consumers based on the hash values. So this will be purely working based on the hash function internally. Broadcast distribution, we can see it in the execution plan as a PX send broadcast. So this method, what it will do is each producer sends all row hits to all consumers. If there are n number of producers, and data will be distributed to all n number of consumers. So equal distribution will be done in this case. Range distribution. So PX send range we can see in the execution plan. So in this method, each producer sends its rows that have a range of values to the same consumer. Next one is a hybrid hash distribution. We can see in the execution plan as a PX send hybrid hash. So this method is decided at runtime by the optimizer depending upon the size of the result set of the left side join of the query. It depends on the query. These distribution methods will be internally used or triggered. Next one is a hash distribution, PX send hash we can see. It usually used when the number of rows to be distributed is high. Next one is broadcast distribution. We can see it as a PX send broadcast. And the number of rows is relatively low. So the cost of the broadcasting of the rows to the parallel servers is not high. At the time, this broadcast distribution will be used. Range distribution, you can see it as a PX send range. Range distribution, it's mostly used in parallel sort operations. Hybrid hash distribution, you can see it as PX send hybrid hash. This is an adaptive distribution method used in the join operations. So how the joins will be called internally, that will be purely decided by the optimizer and based on the complexity of the query about the joins or whatever the operations being used, conditions being used in the query. So what happens when the query determined to be executed in parallel? What are the things will happen? So we can see in the following steps. So the user session or shadow process takes the role of coordinator. Whatever the session triggers the query, parallel query, it will be act as a query coordinator. And it will be called as a QC as we seen in the earlier slide. So the QC session that initiates the parallel statement. PX coordinator obtains the necessary number of parallel processes called as a PX servers. So these PX servers are individual processes that perform the work in parallel on behalf of the initiating session, that is a QC. So the QC acquires the number of slaves depending on the DOP mentioned in the query, whether it's a dynamic or hint or at object level. So the SQL statement is executed as a sequence of operations, such as full table scans or by order by clause. So each operation is performed in parallelism as possible as it can be done. When the PX servers are finished executing the statement, the PX coordinator performs any portion of the work that cannot be executed in parallel. For example, sum operations. So that requires an adding of the sums of subtotal produced by the consumer rows, which are handed over to the QC. So that work will be done by the QC. Finally, QC will be handing over the result to the user or session. Now we'll see how the PX servers allocations will be done. In this case, parallel max servers is 36. So one query, let us say one query is running with 8 DOP. That means 16 PX servers it is using. So the query is running with a DOP4 and using 8 PX servers. So 12 PX servers not used by the statement. So these are available for any statement. So out of here, we can see 12 PX servers are available and the rest 24 PX servers are in use because different queries use based on the DOP, 8 and 4 in this case. So here the available PX servers are 12. So for example, if any query that comes another 8 DOP or 16 DOP, what happens? The available were only 12. So what happens? It will be downgraded to the available number of available PX servers. So in this case, 12 are available. So that statement can be downgraded from 8 or 16 or whatever the DOP to 6 DOP, which is available. So 12 PX servers are available. So to use that 12, it has been downgraded because the other slaves are being used by the other 2 SQL statements, which triggered earlier. And the execution is still going on. That is the reason it has been downgraded to the available number of slaves. So what happens if further queries are coming with a DOP 2 or 4 or 8? So as long as the slaves are available, the query will get. If there are no PX servers available, then the query will be running in a serial mode. So this is where we can see the downgrade happens. This will be in case of a parallel degree policy, in case of auto. Now we can see the how it will be a query coordinator and PX server, how it looks like. So PX servers are performing the activity as per line IDs 4, 5, and 6 here, we can see for the customer table. And line ID 5 indicates the count of the, it is doing a count from the customer table. Each PX server individual results will be handed over to the QC, which is line ID 3. So this, whatever the operations performed the earlier PX servers, it will be handed over to the QC, that is line ID 3. So QC adds up individual counts and to get the final result, which is line ID 1. So this is a handover from PX servers to QC. And for final assembly, that will be done by a QC. So using SQL Monitor helps to easily identify the work being done. So the ones which we are seeing the PX servers in a blue highlighted one. So they maybe you can see the group identification. So that means PX servers, that means slaves are doing the work. So serial execution means you can see a single person kind of representation. The only work will be done in serial execution, that is QC. If we check further in detail on how it looks, what are the operations. So the operations that are processed by a same set of PX server can be identified in an execution plan by looking at a TQ column. So TQ column, we can see it as a Q100, Q102 like that. So the first PX server set Q100, it's reading customer table in parallel and producing the rows that are sent to the another set to Q102 that consumes these records and joins them to records coming from the sales table. So these will be summed up. Customers and table sales tables results were summed up, means joined in this case. So whenever the data is distributed from producers to consumer, we can see it as entry TQ00, like that one in the name column as the in the execution plan. We can see here, which are highlighted, TQ1, 001, and 002, etc. So that means if we see this one, there is a handover has been, means the data has been distributed from producers to consumer. So this way we can identify which operation has been done by the producer or consumer from the execution plan. So we are seeing in the execution plan, we see in the in and out, there are different keys mentioned as P2S, PCWP, and P2P, PCWC, like that. We are going to discuss what all those indicates. So the first one, parallel combined with parent, it will be called as PCWP. So in this case, it will indicate intra-operation parallelism. That means the parallel combined with a parent. And PCWC means parallel combined with a child. So every parent will be having a child. So these are the pair of operations executed by the same set of parallel process. PCWP and PCWC, these are parent and child. We can identify from the execution plan. The next one, P2P, which means parallel to parallel. It indicates inter-operation parallelism. This is a communication. It will happen between the two different pairs of parallel process. And P2S means parallel to serial. So it always occurs in a SQL statement when the parallel process send their data to query coordinator. S2 means serial to parallel. So the table is read in a serial mode, such as small table, and then its data is sent to an operation that is executed in parallel. So here we can see it as a P2S, P2P. So like this, how it will be represented. So here the producers send data to consumer using a hash distribution method. We can notice on the line numbers from 5 to 9, which is the data distribution takes place, the value in and out columns, either P2P or P2S. P2P means we have discussed the data being sent from one parallel to operation to another parallel. And P2S, the data from parallel operation to serial operation. So on line ID 2, data is being sent to QC, which is a single process. Hence, it is showing as a P2S, parallel to serial. So if we see the P2S operation happening somewhere lower in the execution plan, it may indicate we have a serialization point in that plan, which should be investigated. But it depends on the query and how it has been now being used, the complex conditions, etc. So this could be caused by not having a parallel degree set on one or more of the objects accessed in a query. For example, if a query is running with two objects, means two tables it is scanning, and one is decorated with parallel and another one is not decorated with parallel. In such cases, we can see this type of execution plan. So these are the producers and consumers. So in order to execute a statement in a parallel efficiently, so the server process work together in sets. So one set is producing the rows. This we have seen in the earlier slides. So which is called as a producer, and consuming the rows, it will be called as a consumer. So in the execution plan, the parallel join between sales and customer, these are the two tables, uses two sets of parallel process. So the producer scan the two tables, applying any where clause predicates, and sends the result of the rows to the consumers. The consumers in this case, we can see line ID 9211 and 527. Producers do the operation of any PX send operation, that is 929 and 5. These are the two line IDs where the producers do the operation. Consumers complete the actual hash join and send the result to QC, which is a line ID 8 and lines 2 to 4 from the execution plan you can see. The consumers can be identified because they must do PX receive before they can begin the work. And they always finish by doing PX send QC, which indicates they send the result to QC. So from the execution plan, we can see where PX receive is there and where PX send is there. So these are the operations we can identify from the execution plan. Now we can see how to interpret trace in the parallel execution. This will be for any downgrade kind of scenario, or to check any wrong result cases. So these are the commands to enable the trace. This is at session level. In case session level tracing is not feasible, then system level tracing can be enabled. So we can have a SRDC document where these commands can be seen on enabling and disabling the PX trace. These many trace commands were added to get as much as information about the query execution to see what is happening internally. In this case, we are seeing a select query, which is running on a table. There are two tables in this case. So parallel 8, the hint we are using here. So select parallel hint 8 we are using, and one is a C and one is a S, where we have given aliases over here also. So we can see how it is going to look like from the PX trace. Once the trace is enabled and once we capture the required query, so the trace can be disabled. So the commands can be found from the document which is mentioned over there. So when the trace is disabled, we can see the number of traces which are generated for a particular query which we have enabled the trace. So how we can identify this one? In case of session level, we can give trace identifiers, which is our own a way of identification. So that will be easily identifiable. So how in case of system level tracing? So the system level tracing, we cannot give any trace identifier. So the system will be generating the traces for that particular query automatically when the system trace is enabled. In this case, we are seeing the trace name, the one starting with the P007305 pxperf.trace. So in this case, P00, the ones which are starting with all these are slave traces, which will be called as parallel slave traces. The one at the end, ora_13174, it is a QC trace. So that means a query coordinator trace. That means that session which has triggered the query, that will be acting as a query coordinator. So what are these numbers here in these trace names, which is nothing but a process ID, Unix process ID. So for each slave trace name, we can see different Unix process ID. So based on that, the slave traces are being generated. Please make a just key thing here. Just make a note of these traces, how it looks like. So we are going to see how the QC trace looks and how the slave trace is going to look. This is for the QC trace. Here we are seeing for the ora_13174, which is a QC, query coordinator trace. And at the beginning of the trace, we can see this build label, what is the database version, and what is the Oracle home, system name, node name, in case of host name, and release of the host, and version, and what type of machine it is, and the Unix process ID. So here you can see 13174, which is the same, has been generated or added in the trace file name. That is 13174, which is a process ID as well, and that has been added to QC trace name. In this way, we can identify this is the trace name for that particular query. We can identify it like this. And if we drill down further in the QC trace, you can see SQL ID of the query which we have run. So these mentioned or highlighted here over, starting with OBANG. And we can see the objects also. And object ID for the hint, object ID and hint, both we can see over here. And 74585, that is for the table name C. And 74586, that is the object ID of the table name S. And we gave hint aliases as C and S, so that can be also seen over here. So SPM is a SQL plan management. It will show whether it is turned on or turned off. So here, the one which has been highlighted, it shows the internal functions. These are from the optimizer codes. So these will be just to show how it looks like. Each function will be having the different operations internally, which is being performed for the query execution. And KKFDT parallel is possible. In this case, it is showing. So there is no statement type restrictions. This shows the parallelism is possible. The next one, we can see DOP as 8. This means we have given in the query DOP as 8. So here the table name is S for this particular object ID ending with 586. And use the degree of parallelism from the hint. How it has been derived means from the hint it has been derived, computed from the hint. And we can see total number of CPU count as well. And what is the DOP computed. Here the same, it is statement hint forces DOP 8. That is the reason it has picked the parallelism 8 for this particular table, which is a C. And automatic degree of parallelism is disabled, hinted, because it is showing as a hinted. And the force parallelism property showing as a hint. And the computed, it's no, and force DOP is 8, because we have force to query with the DOP 8. Optimizer will try to find a different query transformations internally. It will check multiple ways internally, what conditions or what is the best suitable access path to get the faster result. So we can see single table access path like this one. What is the table and what is the alias? And it will check the cost and what is the cardinality for each type which is being generated internally. So it will choose the best access path based on the multiple internal ways of generation. Like this, it will be doing assessing the IO cost or CPU cost and the total CPU, scan CPU cost, etc. And we can see it is the best join method. It has been used a hash method. So it's a distribution method, which we have seen in the earlier slides. So the best which has been defined like this one, which is a table 0, cost 6, and cardinality that much. Now we can see the plan signatures. The parallel queries will be having plan signatures. That is to match with the query coordinator and slave traces. And these plan signatures should match exactly with the slaves. So there are different plan signatures as seen in the screen. So these are all internal functions or internal signatures which need to be matched. Otherwise, we are going to see error or wrong results. So this is the simple example of the query from the trace, means what it has been chosen the execution plan. DOP trace, you can see, call 8 slaves. And what is the instance name? What is the, whether it is a PDB or not? How many number of CPUs? What is the max number of slaves available? That is parallel max servers, etc. We can see it from the trace. So these are different entries which are recorded in the QC trace. Every QC will be having its own queue, which will be called as a new queue. It is starting with the 0x6A. So each server will be having its own queue, and it will be under the new queue, which is QC queue. We can see how many slaves we have requested and how many slaves got allocated so far. We have requested 8, so 1 so far, like that we have got received 8 so far. So this we can see acquired 8 slaves. So whatever we have requested, all the slaves were allocated. So there is no downgrade in this case. These are buffers. What is the buffer length, buffer size, and all it will be recorded internally for the as we have enabled the trees. So here we can see the slave informations. So signaling error, that is, it can be normally ignored. It is not exactly any issue or anything. So whatever the slaves which are here acquired 0.0, slave is 1.1, 1.2, 1.3, like that. So you can see the DP values over there, which is 1108 and 11C8, like that, etc. There are queue names we can find and the DP. What is the DP? And DP and the queue name, we can see it is matching over here. So once the execution is done, the releasing of the slaves will happen and the queue will be cleaned up after the execution. So we can see message buffers has been freed up and the slaves will be releasing after the execution. So whatever the queues initially requested, that will be getting cleaned up and it will be deleted at the end of the query execution. So this is the slave trace. We can see P007305 trace. And we can see the signatures are exactly matching. That has to match exactly. Otherwise, we are going to see errors or wrong results. So these signatures will be there in each slave and each will be identified based on the queue name and the DP, which we have seen in the earlier slides. And we can see the execution plan also in the slave traces. So here QC instance 1 and SPID, all this information, we can get it from here. Now we'll see the PX error trace. So to get, if there is any 12850 or 05 or whatever the parallel related error, we can get it, the similar trace for errors. And here in this case, we are seeing there is a mismatch happened. That is the reason that error 12850 is occurring. So in any case, if these kind of things will be, most of the known issues will be there. So that can be checked by contacting support or through a different ways. And here also we can see there is a plan signature mismatch between QC and slave. OBJ, which is starting with, which has been highlighted, it has been as mismatch. That is the reason it is causing an error or issue. There are multiple ways, multiple mismatches also occurs as shown over in this slide. And in case of errors, we can enable particular error trace. So we'll come to know what is the exact error which is causing the issue. Sometimes parallel will be a victim. The actual error might be leading and which is followed by the 12850 or 05 or 01. So This is the Y1722. In this case, 1280 is the victim, and the actual error is 1722. You can see the bind values. What are the bind values has been used, different one based on the error trace. Yeah, that's all for today. We have covered these topics today: parallel execution basics, what are the terminologies, architecture, and distribution methods, trace interpretation, and diagnosing the common errors. These are the articles or white papers used, and it will be useful to get more information about the parallel execution. We have a community thread as well to reach for any parallel related for you.
That's great. All right, thanks, Praveen, for that very informative presentation. We're going to open up to Q&A in just a moment. Please go ahead and use the chat panel to ask any questions. And while we pause to collect your questions, I'd like to share some information on locating Advisor Webcast and how you can access the recording from today's session. This Advisor Webcast document, 740966.2, is the starting place to find out about Oracle's Advisor Webcast program for all Oracle products. And the first tab of this document provides a link to the registration page where you can register for upcoming sessions. For today's webcast session and a list of all prior webcast recordings, you can go to the Prior Webcast Recording tab and then click on the recording link. A PDF file with the webcast session slides can be downloaded from here. If you have any follow-up questions on the webcast session, use the community link. The Q&A from today's webcast will also be posted to this thread, as well as any responses to the questions that we may not get to during the webcast. And a recording for this webcast will be available within 48 hours, which you can access directly from the KM document listed on your screen. And I've also posted this information in chat for your reference. I also want to mention that you can visit the Oracle Support Advisor Webcast landing page, where you can find a listing of all upcoming Advisor webcasts across all product lines, and you can register for any webcast that may interest you, or also provide a listing of all the webcast replay links from the past month on the In Case You Missed It tab. And I've posted a link to the landing page in the chat. Okay, next slide. We're going to open up for questions. So to ask a question, please use the chat panel. And just a reminder that if we can't get to the questions and we're not able to answer them during the webcast, we will, of course, post those to the community thread. So one of the first questions we had was, given that PX can be good or bad depending on each SQL, what is the real-life use case for alter session force parallel X?
Session level parallelism can be used in case if you wanted, if there are any resource crunches there, and if any query need a faster execution, which has to be run in the parallel, then the session level parallelism can be enabled. And to enable the parallelism, it is good to have an object with a larger size, at least in more than 1 GB or greater than that. So that is a good or ideal to execute the queries in the parallel.
All right, thank you. And you'll have to forgive the noise. There's a bit of construction going on. Another question on rack. Let's say you have 4 nodes. Some users have seen that spreading the PX slaves and all the compute nodes spikes the rack GC weights unacceptably. Is there a metric that can help decide whether it's better to use parallel force local equal to true to avoid this? Like, is that a good option?
Yeah, in case of rack parallel, when parallel queries are triggered, the slaves will be spawned across the instances. So that is the default behavior. So initially it can be checked if the enough PX configuration is there or not. If there is a scope of increasing the parallel limit, it can be checked. In case if you have decided to run or spawn the parallel slaves at any one of the instance, then parallel force local can be set as a true. So it's based on the usage of the parallelism in the database. If the spike is coming due to parallel execution, then it can be checked in case needed. So that can be investigated. Or parallel force local can be set to true as well, but it depends on the requirement or how the project requirements are demanding.
All right. Thank you. A few more questions here. Will the SQL scale back up when more CPU is available, like when another query completes?
Yes, for example, if query running with 8 DOP, so it acquired, let us say it acquired all the available parallel slaves, so 16. So if another query is coming with 4 DOP, it requires 8 parallel slaves. So once it is started, its execution means when the previous query is still not completed means it will run in a serial mode. For example, if the second query is started its execution, and by the time the other query is releasing the slaves means it will take some time to get the free or available slaves. By the time this second query execution might have completed. But yes, when the slaves are available, the upcoming queries can be used the freely available slaves. But there is a upcoming feature. So where whenever the slaves, producers and consumers doing their activity, when it is finished, those will be going to release then and there. That will be a new feature which is going to be coming in.
Okay, great. Is it possible to explain how the auto DOP is calculated?
DOP is calculated, it depends on the degree we are using. If it is a 2 parallel decorated with the 2 means object is decorated with 2 means that 2 into 2 PX server sets it will be using. So whatever the DOP and multiplied by the PX server sets, it will be calculated. And it depends whatever the parallelism being used in the database, it's completely depends on the parallel max servers value.
Okay. And is there an easy way to measure the amount of undo, redo, and temp space that a certain SQL statement consumes in serial mode, let's say, versus parallel servers execution?
Oh, it need to be monitored like any other way. Whatever the way which is being checked in the serial execution, it can be done in the same way for the parallel execution. It can be compared maybe using the traces or while running the query, check how much amount of the undo are being generated or used temp, how much it is used by comparing the parallel and serial executions.
Okay. And we're at the top of the hour, so just one more question. How much PGA size is important for parallel execution?
PGA parallel execution mostly depends upon the CPUs and the SGA. So the PGA, it can be checked based on the PGA advisory, what is going to be required for the database. It is not only specific to the parallelism.
Okay. Well, that's great. There were a few more questions in the chat, and I will leave the session open just for a few more minutes just to collect those questions. And of course, they will be answered and posted in the community thread. I'd really like to thank you, Praveen, for taking time to present this informative session. And of course, to our panelists, Jay and Pradeep, for answering questions throughout. That was very helpful. Well, I hope everyone found the webcast today valuable. And again, as a reminder, this webcast and PDF of the output will be available within 48 hours. I like to thank you all for taking time out of your busy days. And that concludes our webcast. Thanks, everyone. Have a wonderful day. Bye-bye.